As I mentioned previously, we have two very special guests on hand with us today. Our first guest is Mr. Bill Clinton. Bill is a professor in the School of Architecture at Montana State University. Bill has been teaching graduate level design, construction, and materials classes since 2003, and is the fabrication shop manager as well as the equipment and facilities manager for the School of Architecture. Bill has created a digital technology room which houses laser cutters, a rapid prototyping machine, a 3D digitizer, and two 3-axis CNC machines. About 350 students in the MSU School of Architecture learn CNC laser cutting, 2- and 3-axis milling, additive manufacturing, as well as rapid prototyping. Bill will be discussing how RhinoCam has been introduced into the curriculum there at MSU. Bill, welcome to the webinar. Tell us about your use of RhinoCam there at MSU.
We have used RhinoCam for about, I'm going to say 8 years. We introduced this program into our curriculum in second year. We have a 5-year program here. Start off very, very simply with having them mill foam. And they learn 3D tool paths, they learn 2.5D tool paths. And many of those students who learn RhinoCam in those very simple sessions go on to really love the CNC machine in particular. They realize at some point that they can create these 3D shapes that are almost impossible to do any other way. And then I introduced it again in my classes. I teach 5th year graduate level design build class. Let's just change slides. We'll talk about some of the work. This is a class that I taught several years ago, and I asked the students in this class to work collaboratively and design a machine that would indicate the passage of time. And we're obviously used the CNC extensively with this project to make the gears, to make the case, to make the mold, to cast the lead weight even. We used the RhinoCam and our CNC machines to do all that. What you see in this picture are students assembling the last mock-up that we did. And in the upper right-hand corner, you'll see the gears being cut. To get as flat a material as we could, we made our own plywood in vacuum bags. So we used 16th-inch veneers, cross-laminated the veneer, and made very, very flat wheels for our clock mechanism. It performs well. Actually, it's still running. It has to be wound once a day, which is the problem. I just told them they had to make a machine that would indicate the passage of 24 hours, and this is what they came up with.
That's nice.
We can go to the next slide, I think. I'm a musician, and I incorporate music into the architecture program. There'll be a couple slides later on that we'll talk about that. But for me personally, my research has been into building instruments, and I'm a guitar player. So I decided that to build an electric guitar, which is my main instrument is electric guitar. And I wanted to build as much of it as I could. And building a bridge was important to me because I have certain parameters that I use when I play, and I like the feel of this aluminum bridge. So it was a challenge, and the students, it was fun to see them watch me do what I was doing, and then suddenly a whole bunch of students wanted to make electric guitars. It's kind of funny. But in this case, we're seeing an image of the bridge, and it was the only thing I had to do with this bridge is polish it, actually, after it was milled, and that may have taken probably almost as long as it took to machine the bridge. We do a lot of wood machining, and you can see the body and the pick guard and the neck of this guitar was made from wood. We also mill metal to a certain extent. Students, one of the things that I have to teach them is materiality and connections, and they're pretty unsure about how fast a router needs to go, especially when they get to metal. So they're pretty tender about approaching the metal part, and I know it's helped that when I'm in the shop doing my own work, they see it and they go, oh, well, I can do that too. So it's been a fun thing. I've made several guitars, and I'm on to my next iteration this semester. So
That's nice.
Well, thank you. We can change slides. This is in the upper left-hand corner. You'll see an instrument that I built. It's a glass-keyed xylophone, and the machine was used for lots of stuff on that, but mostly you'll see in the right-hand corner there the mold that cast the silicone rubber that holds the glass keys for the xylophone. And again, I'm trying to teach students about connections and materiality, and frankly, it's hard to teach a student how to be a furniture maker in 15 weeks. It's hard to teach a student how to understand the whole depth of craft in 15 or 16 weeks. And so I try to, what I really want to get out of this, the courses I teach, is connections and materiality. Lots of students come into this class having never used a power tool ever, of any kind. So it's a pretty steep learning curve for them. The drums you see in the lower corner, or the lower part of the screen there, a student milled all those parts on CNC. He had to mill both sides of the sheet, which took some explaining how that worked, and that was, and also the connection in the middle was machined on the CNC. And that's another thing. We talk about jigs, how you can use the CNC and Randocam to make jigs to make a piece. So there's that whole other level of learning when it comes to making parts. Making a tool to make the parts sometimes comes into play. And I think we can go to the next slide. This was a really interesting project. We were asked to be part of a collaborative effort with the School of Architecture and some geology students and geology professors to make a site model of the Bay of Naples, sorry, for the Atlantis exhibit at the Museum of the Rockies, which is currently running now. This exhibit there's only 3 museums in the country that is coming to. MSU is the largest and the longest running exhibit, and it's also the most expensive exhibit the museum has ever mounted. So we knew we had to do the right thing, and our students came through with flying colors. As a matter of fact, we're up for a university award for this project. No other museum is doing this kind of stuff, but we realized that we could collaborate with geology and create this a site model of Bay of Naples, and concurrently with a video that's running on a wall, the projection from overhead projection onto that surface is chronicling the eruption of Mount Vesuvius that affected the Atlantis villas, which would be sort of, I guess you can see it there, that orange section. That's kind of where the Atlantis villas were. This was a really interesting collaboration. We had students who were geology students who knew everything about geology but knew nothing about CNC, and we had vice versa. Our students could run the CNC machine and understand how to do that, but they didn't know anything about geology. So we collaborated, and with this site model, converted pretty extensive, high-definition files from the geography of that region into point clouds, and then draped the point clouds and cut that model out of high-density polyurethane foam. And I certainly checked that file about 20 times to make sure, because that piece of foam cost about $900. So we wanted to make sure that we wouldn't have any trouble, and we didn't. And it has been very successful. This model will probably go back to Italy. These objects from the Atlantis villas uh, I've never been out of Italy and may never be again. And it sounds like all the stuff that we created will be going back to Italy, which is kind of cool, actually. We're excited, and there's some hope that not only will the models go back, but we'll go back with the models. So I'm really excited about that possibility.
Hey, Bill, I'm wondering something while we're looking at this picture. Where did you get the topology, 3D topology for the RhinoCam topology to cut this part?
You know, that's a really good question, and I can't exactly answer that question because it comes from some really high definition files that that geology had given us, and they were such high definition and so dense that we actually had a little bit of trouble with it at first, and not with the milling part, but with translating that point cloud data into a drapable surface.
Yeah.
So we worked with the students, and I can't tell you the exact program they were using, but it's something kind of proprietary to geology that I don't think is available to anybody.
Nice.
Yeah, it was a good project. We, like I say, we formed some bonds, and these collaborative projects always turn out well for us when you get a group of students who are interested and engaged, and that's a wonderful experience when it all works.
Okay. Well, I appreciate that, Bill. That was great. If you could, Bill, please stay with us for the Q&A session at the end. Some of our attendees may have some additional questions. I appreciate that.
You bet.
I have one question initially. Given the age differences of your students, I'm just curious what CAM concepts you feel are more difficult for them to learn than others.
One of the things that we deal with is we're not teaching students how to do this as a career. We're teaching them how to make stuff. So one of the hardest things that I have to teach them is just the material itself and how to mill it. How fast can you cut wood? How fast can you cut metal? The hardest thing for me is just that. They understand the digital world. They're comfortable in that. And for me, it's just the stuff that most of us who make things already know.
Great. Also, I'm curious. Also, if you have any questions, please type them in the chat window. But I'm wondering, Bill, let's go to you. How did you, or what process did you use to create the curriculum for your classes that include the RhinoCam?
Well, we do have a structured second-year graphics program. The students learn how to use Rhino, and that's the start. And then we have them mill small objects, and mostly it's chunks of foam, about 6 by 6, and we've introduced it into the graphics program in second year, and then the students all know that the shop's available to them from that point on, and they some students don't use it till they get in my classes, and I teach not only these classes we talked about today, but dedicated furniture design and chair design classes, and then they come back to it. Some students really get interested and keep going with it.
Great. Any more questions, everyone? Just type them in.
Well, I'd actually like to make a comment here. We talked a little bit about this earlier before we went on the air. We've been using RhinoCam for a long time, and I just can't say enough good things about it. Joe and Anita, Uday and Don have been absolutely impressively responsive to our needs, and we use the Campus Cam. It's performed without a flaw for us. The company, your company, and I swear you didn't pay me to say this, but you guys have a quality product, and the way you structure your education and the way you sell your products is absolutely the best.
Well, we appreciate that, Bill. We also appreciate you taking the time.
Well, and if there's anybody, and I'll offer this to anybody that wants to contact me personally, if you don't feel comfortable talking on this forum, please call me. Please email me at Montana State University. I'm in the directory. I'm the only Bill Clinton on campus, so I'm more than happy to help anybody out.
Okay, well, I appreciate that. Any other questions, Joe?
I just wanted to thank Bill for his support. We've known Bill for a long time, and he's always been there to help us out. And he's come out here for training, and we met him, and he's just an incredible guy. And he's a very talented person, so you can talk to him. And I hope, Bill, you don't regret your comment about having people call you, because we are recording this, and we're going to make this available to a lot of people. So you might get a whole bunch of calls.
I hope so. Thank you, guys.
Thanks, guys. Well, that concludes our webinar for today. I want to personally thank you, Bill, and Drew for taking time out of your busy schedules today to be with us. I also want to thank all of you, our attendees, for joining us. We're very glad you could attend. We hope you walk away with some helpful information about MecSoft's CAM products in education.